using Statdisk for inferences about two proportions. This video uses example 1 from section 9-2 titled Large Denominations Less Likely to be Spent, and example 2 from section 9-2 titled Confidence Interval for Claim About Denominations. When using Statdisk for inferences about two population proportions, you must know the sample size n and the number of successes x for the samples from each of the two populations. For either sample, if you don't know the number of successes but you know the value of the sample size and the sample proportion, you can calculate the number of successes by multiplying the sample size by the sample proportion. Then, round the result to the nearest whole number. For a hypothesis test in which we are testing a claim about two population proportions, use the following procedure. First, select Analysis from the top menu bar, then select Hypothesis Testing from the drop-down menu. Select Proportion Two Samples from the submenu. You should now see the Hypothesis Test Proportion Two Samples dialog box. Under Alternative Hypothesis, select the type of test, two-tailed, left-tailed, or right-tailed. Select the option that uses the same symbol as the alternate hypothesis. For a two-tailed test, select the first option, Population Proportion 1 not equal to Population Proportion 2. For a right-tailed test, select the second option, Population Proportion 1 greater than Population Proportion 2. For a left-tailed test, select the third option, Population Proportion 1 less than Population Proportion 2. In this example, we select the third option for a left-tailed test. Next, enter the desired significance level. In this example, we enter 0.05. Proceed to enter the sample size and number of successes for each sample. In this example, for sample 1, we enter 46 for sample size and 12 for number of successes. For sample 2, we enter 43 for sample size and 27 for number of successes. Click Evaluate, and the results will be displayed as shown. The results include the test statistic z and p-value. In this example, because the p-value of 0.0002 is less than the significance level of 0.05, we reject the null hypothesis of population proportion 1 equaling population proportion 2. Because we reject the null hypothesis, we conclude that there is sufficient evidence to support the claim that population 1 is less than population 2. In other words, there is sufficient evidence to support the claim that people with money in large denominations are less likely to spend relative to people with an equivalent amount of money in smaller denominations. The results also include the confidence interval. In this example, a one-tailed hypothesis test with significance level of 0.05 results in a confidence level of 90%. The confidence interval limits do not contain 0, implying that there is a significant difference between the two proportions. Because both confidence interval limits are negative, the confidence interval suggests that the value of population proportion 1 is less than the value of population proportion 2. There does appear to be sufficient evidence to support the claim that money in large denomination is less likely to be spent relative to an equivalent amount in many smaller denominations.